So hey everyone, welcome back to our daily LeetCode challenge series. So today is day 77 and yeah, today we are going to solve LeetCode problem 100, same tree. So this is an easy level problem and it's related to binary tree. So let's see the problem statement first. So we have given the roots of two binary trees P and Q with a function to check if they are the same or not. Like most of you are aware about like what is binary tree. Basically the root node, parent node we can say, and every node like at max have can two nodes that we call as binary tree, and this is basically non-linear data structure, right? And basically one node is pointing to another node using the same reference, right? So like two binary trees are considered the same if they are structurally identical and nodes have the same value. Okay, so in example 1 we can see we have given two binary tree. One is the parent node, or we can say root node, which is having left child as 2 and right child as 3. Similar way the second is same as well, like left is 2 and right is 3 and one is the root. Fine, so we can say here it is identical, right? So that's why we're doing true. Fine. In example 2 we can see the parent node or root node is 1 and left child is 2, but there is no right child. But in the second given tree, binary tree, like one is the parent node, that is like same, but there is no left child. In the right side we have two, so we can't say like this is identical binary tree, right? Because it is having consisting of right left node, and the first one is having left lead node with the same value, right? So in this case if we can say it is not an identical binary tree, right? So ideally it should be in the same, either in the left and either in the right only. Now we can say it is a mirror binary tree, right? Fine, so that's why we're getting false. In example 3 we have 1 2 and 1, here 1 1 and 2. Even here we can see like in both one we have the left and right leaf nodes, but value is different. The first one we have the second in the left side and first in the right side, but in the second binary tree we have first in the left side and second is the right side. So we can say this is not an identical, it's a mirror binary tree. Fine. So constants we have given a number of nodes in the both trees is in the range of 0 to 100. Fine. And node of value can vary from minus 10 to the power 4 to 10 to the power 4. Okay, so this is within the range of integer value. Okay, so we don't have to worry about the storage of the value, right? And in the left side we can see the definition of binary tree is given tree node, which consisting val the node, left node and the right node, and we have constructor with the value and with that left and right tree. Fine. So I think it's not that much hard, it's a quite easy one. What we can do, we have given the method it's same tree, which is having two attribute like P and Q. Fine. What we can do, first of all we'll do some base case. Base case will be, we have to check P dot value. So P dot val we can compare if it is equal to null, right? That means like there is no left and right child, right? And tree is empty. Similar way we'll compare Q dot value val. If it is also null, then we can return true, because in this case both is having null parent node, then we can return true, right? So in this case it will always be a identical binary tree. The second best case what we can do, say we can first check P dot value is not equals to null, right? Similar, and Q dot value is also not equals to null. If both is not null, right, then we can check if P dot value is equal to Q dot value. So if both is not null, then we have to compare their value, right? If both values same, that means the current node is having the same value, then we can iterate to the either left and right. So in that case we have to check the left and right node both. So what we can do is I will call recursively the same function. So I'm calling same tree that is already given, and here we'll first pass the left node of the first tree and the left node of the second tree. So in order to do that, we can pass the value for the next pointer. So pointer is none other than q dot val, right? Similar way we can pass here we should pass the left node, right? So then we say q dot left, and second will be p dot left, right? Both should match, and now we'll call same for the right node. So we'll call the same method, then here we'll pass q dot right, same p dot right, correct? So if both again recursively it will call, it will check the scenario. If it is same, then it will go till the last node, right? Now if it is not so, then simple return false. If any of this is getting mismatch, will return false here itself, right? Fine. Let's submit and see the test cases. Okay, so the problem here is dot val, like even there are some case we can't directly check the value, so we have to check the current tree node. If it is not null, then only we can check if it is having some value or not. So that's why we are getting this error. Even in this case, we have to check if it is not null, then only we'll check the value in the next check, right? So here we are checking if it is not null, then only we are comparing the value. So this will be safe, right? Okay, fine. Let's submit and see. Hope it will work now. So yeah, we can see our all three test cases got accepted. Now submit and see your test case as well. Okay, so yeah, like all 67 test cases got passed and it beats 100%. So like our solution is optimal, right? So yeah, if we talk about the time complexity here, so time complexity in the case of binary tree mostly depends on the height of the tree. Height means like the amount of the lead nodes that we are iterating. So in this case we can say it is big of n, and like denoting the maximum height of the binary tree among both, right? And in a space complexity it is remains constant, like we are not using any extra space here, right? So it is a big of 1. So yeah, that's all for today. Let's see you next video.